right, let's get on to lab 7. Lab 7, we're also controlling the speed of our cylinder, but as opposed to throttling the fluid coming out of it, we're actually going to use a pressure compensated flow control valve. So essentially what's going on is we're going to see that the flow rate is changing and consistent, but what's going to happen is that depending if I change the pressure, because it's compensated, the flow rate's going to stay the same. Because in the last lab, we saw that if I changed the pressure, the flow rate changed. But in this case, I'm going to change the pressure, and my pressure compensation valve is going to deal with that, and it's going to make sure that my cylinder's going to move at the same speed, and my flow rate's going to be the same. So let's hook this thing up. Okay, again, first thing I'm going to do is hook up what I need to hook up without thinking. I'm just going to go in here to my pressure. And then I'm going to go over to my tank. And I'm going to look to see if I need a drain. I know I don't, but it's always good to check. And then from there, I know that I want to watch the pressure, so I'm going to stick this guy on here and put it to my pressure. Okay, so now I have to think. All right, so my thinking is going to take me through a nice simple process where I'm going to hook it up the way that the flow is going and the way that I'm studying the flow. Okay, here we go. So I am looking at my circuit, and my flow that I'm going to study is actually coming out of here because I'm actually kind of metering out, but I'm pressure compensated metering on the way out. So anyway, but that's how I'm hooking it up. So I'm going to go from here and hook it up to there. So the first thing I'm going to do is hook up a hose from here to my extension. And before I go straight into there, I'm going to put this guy on because I want to study the pressure in there. Okay, now this is where my circuit gets a little complicated, so I have to kind of really think about what I'm doing, make sure I get it right. Get it right the first time, you won't have to do it again. Okay, good. So, out of here, I'm actually going into a place that actually has 4. Now, this circuit that you're seeing here where my thumb is I had to modify this just a little bit, but the circuit you'll have in your lab is the right one. What's happening here is that we are, give you a look at this. We're actually coming out, the fluid's coming out of the cylinder, and it's going to go through my flow control valve because I want to study it. It's going to go through my pressure compensated valve because I want to be able to control it. But again, just with anything that we have where we're metering, we need a check valve. In this case, my check valve is going to be in parallel with both of these things in series. So, but that wasn't like that, so I had to modify my circuit a little bit. But you'll see in your lab it's like that. Okay, here we go. So, let's hook this guy up. Out of here, I'm going to have to go to 3 different places. So, I got a couple different options, but what I want to do is grab one of these that's a 4-way. So, I'm going to put this right on here, and then I've got 4 connections that I can work with. Okay, good. So, now I'm going to go back to my drawing and make sure I hook this up right. So, I know that in the end, I kind of like to hook up my check valve last, so I'm not even going to worry about that. Right now, I got 2 things that come out of here. One is I want to check the pressure, okay? So I'm going to put that under my pressure. I'll use a short hose here. And I want to study the pressure there. And the other is that I'm going to go directly into my pressure compensated flow control valve. And now that has polarity. You've got to watch, make sure you get the polarity right. And I can use a short hose here. In this case, I'm going to go to here. Now, I want my flow to go this way. So I want to make sure that the flow coming out of here is going to go in here. So it's going to the in. And now I'm going to come out of here. Like I said, I'll deal with my check valve last. Okay, I'm going to come out of here and I'm going to go into my flow meter. Okay, good. So, a longer hose for that. Coming out of here, going to my flow meter. Again, I have to think about which way I hook it up. The flow through the meter is going this way, so I want to go into the in with this, which is on the bottom. And then from there, I'm going to come out. Now, I have to think about what I'm doing with my check valve. Right, my check valve is not across this, it's across this and that in parallel. Okay, good. So I can continue, but because I'm coming out of here, I need a T here. So, I got that guy. So, now I'm going to continue on with this and I'll do my check valve later. So, out of here, I'm going to go back to my DCV. Out of there, into my DCV. Now I can hook up my check valve. Now I have to be really careful about how I hook this up. The polarity matters. Okay, good. So the fluid is coming out of here. I want it to go through my meters, so I don't want it to go through my check valve. So I'm going to put it in the way that it's blocked from my check valve, or I can just go back to the drawing. However you do, make sure you hook up your check valve right. So I'm going to go to my drawing and I'm going to see this side goes to the ball side of the check valve, right? Because it's actually being blocked. I want to force it to go through my meters. Good? Now my other side of my check valve goes here. It's going to go into my other T-fitting. Perfect. Okay, before I move forward, I want to make sure I have no open connections, everything looks good. I look at my circuit, I'm like, yeah, I hooked everything up. Okay, let's press play and go. So, I'm going to start this thing at 250 again. I'm going to make sure my pressure's off, that's open, this is in the middle, turning it on. I'm going to slowly turn this down. We're good. Okay, let's take this up to 250. Let's see what's going on. Now, I want to slow this thing down in extension. I'm doing that with a pressure compensated flow valve. So I want to get this to a nice easy setting. So let's actually get it to a normal. Let's put it to 1 again. It's at 1, so that's good. So I'll back up. Using a different valve, just happens to be set to 1 at this time. So I'm going to go with that and leave it like that. Now, what I'm going to do is I'm going to crank the pressure up and run it again. Let's watch the pressure here and here at this setting. Ready? Here we go. Now, watch this pressure here. Okay, now that guy is going up higher, and we know that because the fluid, we're studying the fluid here before it goes through my pressure compensated valve. And the pressure compensated valve, it's kind of stopping the fluid from going. It's acting like a throttle valve. It actually is a throttle valve, but it just has pressure compensation. So that's why I'm getting higher pressure here. Let's take a look at the pressure going into my cylinder as I'm running this. Into my cylinder. Okay, it's pretty high, and the reason is because there's a back force happening here. Because of the high pressure. The pressure and force, obviously, they work together. Higher pressure, higher force. So there's back force here. So I'm seeing pressure here. If this thing was wide open, it had no flow restriction at all, we would see that to be a very low pressure. See? It's next to 0. That's because this thing is just free to move. There's no back pressure. Okay, I have to reset this thing back to 1 gallon per minute. Let's try that. Okay, here we go. Yep, that's 1. So we'll leave it like that. I'm going to back it up. We will see that the flow rate doesn't change when I increase the pressure. Let's put the pressure up to 250. Okay, I'm at 250, and let's watch that flow rate. Before it went higher, it's still at 1. It's still moving at the same speed. And you can time that to see how fast it's moving. And you'll see that it's the same amount of time. So in retraction, now I'm going to kick my pressure up to 500. And again, we'll see the flow rate is the same. Now, whoa, look at that pressure. It's huge. And it's still 1. So this is really, really high because this guy is still dealing with kind of managing the same flow rate, but because the pressure is really high, it actually creates a lot more back pressure in the system, and we're seeing that. And that higher back pressure exists because my system pressure is higher, and it's having to manage that back pressure, or more specifically, is managing more of the back pressure, and we see it in this line. So, I'm going to shut this thing down. I'm going to put it in retraction. Nice and quick in retraction because the pressure was so high. I turn this guy off, open this guy up, and I'm shutting down. All right, there we go. Lab 7, now you're experts.